Okay, so lesson 6, we're solving radical equations. Now, before we get started into radical equations, they're just going to give you a brief introduction to a radical expression. Okay. Anybody not have a graphing calculator on them? If you have a phone, you can go to a free graphing calculator site. Just Google Desmos, DESMOS. So if you don't have a graphing calculator, I also have a couple if you want to borrow. So okay, so consider the radical expression square root x. Okay, so you're going to go into your Texas Instruments calculator, or if you don't have a calculator, go to desmos.com. And you're going to type in square root x into your graphic calculator, and we're going to analyze what this graph looks like. And what we're going to focus on is the domain. So how to put that in, you just go square root, so second square, and then type in an x. Okay, so you have square root x. And then just hit graph. I'm going to hit zoom 6 to make sure I have the standard window, and then this is the picture that we have. So I'm just going to leave it like that, and you can take a look at it. And what kind of observations do you guys have on this? Which way does the graph go? Positive x only. Why is this the case? You can't square root a negative. Good. So we got a couple people seeing this. That's good to see. You cannot square root a negative value. So for this expression, you would write a domain restriction. You say x is 0 or bigger. Because the square root of 0 is fine, but the square root of negative is not fine. So it's going to be 0 or bigger. Okay? So let's take a look at this graph. What happens when you square root 0? You get 0. What happens when you square root 1? What's the square root of 1? 1. And then the next nice one is square root 4. What's the square root of 4? 2. So then you get this shape like this that goes on forever like that. Okay? So those points again were 0, 0, 1, 1, and then, 4, 2. Okay, square root of 4, square root of 1, and square root of 0. Those points there. So those are the good ones. This is the square root function. Okay, so it says for what values is the radical expression undefined? This would be x strictly less than 0. If you're strictly less than 0, this is not going to work. Okay, so let's jump into the next one. Okay, so now instead of square root x, we're going to have square root of x minus 2. And observations on this one. Is it the exact same thing, kind of just moved over? Alright, so it just means that we have a new starting place. Instead of starting at 0, the domain starts at 2. Okay. So now, when you put in a 2, starting at 2, what happens? If you put in 2, you get the square root of 2 minus 2, which is 0. What happens when you put in 3? 3 minus 2 is 1, square root of 1 is 1. And you basically have the exact same thing, just pushed over to the right. Okay? So where does this one start? It starts at 2. So you say the restricted domain, you could write that in to remind you what this is. It's a restricted domain. It has to be greater or equal to 2. Because if it's 2, it works. If it's 3, it works. If it's 2.1, it works. If it's 2.01, it works. But what happens if you're 1.9? If you're 1.9 and you subtract 2, will you become negative? What if you're 1.99? Still negative. What about 1.999? Still negative. So you can get really, really close to this, but it has to be at 2 and starting at 2 and moving forward. Okay. Now to do this algebraically, you're going to think back to the original one right here. You have to think back to the original. So for the original, what happened? X was greater than or equal to 0. Now what we can do is we can change x to whatever function we want. For example, you could change it to x minus 2. Okay, sorry about that. My mic just died. So back to the board. We were saying that for the original, if it's root x, then it's x greater or equals 0. We can replace x with anything, for example, x minus 2. So then you would say, okay, well then x minus 2 has to be bigger or equals 0. So inside this, we call this like the argument, or the radicand if you want to call it that. Call it the radicand. So basically the radicand has to be greater or equals 0. And then you just solve that. So move the 2 to the other side and you have x greater or equal 2. Okay, so let's try this on the last one. Remember, it has to be radicand greater or equals 0. What's my radicand? 3 minus 2x. As long as 3 minus 2x is greater or equal to 0, you're safe, so to speak. It'll work. The domain will make sense. So how do we solve this one? Have you ever remembered in junior high, like if you divide by a negative, the inequality flips? I don't ever want you to ever have to worry about that. So move the negative to the other side. Now divide by 2. And the solution is now x less or equal to 3/2. You can see that x, and then it points to x, so that means less than 3/2. So go to your graphing calculator and double check. So 3 minus 2x is the new argument. 3 minus 2x. Graph that. And there you go. If I zoom that in for you, or else change the window to -5 to 5. You can see it hits right there halfway between 1 and 2. So that would be 3. That would be 1.5, and it's to the left. You see the graph is going this way. So all your x values are less than 1.5. Okay, so you go this way. Let's get that sketch on the graph. So where's 1.5? About here. And then it just has to be a sketch. Doesn't have to be perfect. That way. Okay? So what's the takeaway from this? M? Jordan, we'll give her a tap. You with us? All right. So what's the takeaway from this? You're going to be asked on quizzes and tests to determine the restrictions. Okay? So put a star on that. And this is the starting point. You need to be able to show that the radicand is greater or equal to 0, and then you go ahead and solve. That's going to be on your exam for sure. And the quiz. This is called domain restrictions. Next page. So we need to algebraically determine the restrictions on x. So what are the restrictions on x? Let's take a look at the first one. In order for this equation to make sense, this thing inside the house has to be what? 0 or bigger. Or else you're going to be square rooting negatives, which is not allowed. So you say 4x plus 1 has to be 0 or bigger, so greater or equals 0. And then it's just basic solvings of algebra. Move the 1 over, and then divide by 4. So x has to be greater or equal to a quarter negative. So I'm going to put a note on here. If you divide by a negative, the sign flips. I will never ever do that in my notes, because if I have a negative coefficient, I just move it to the other side, then it becomes positive, and I never have this situation. I don't like remembering these little rules like this, okay? So I would try to avoid that at all costs. Okay? And hopefully that comes up so I can demonstrate it. Yeah, it shows up on the next one. Okay, so for the next one, it's only the thing under the radical, so the radicand. 2, that 8, we're not interested in solving yet. If we were interested in solving the equation, we'd use 8 and we'd do some extra stuff. Right now we're only working on which values of x does this equation make sense. These are called domain restrictions. So this equation only has solutions for certain x values. Let's do the next one. Remember, the radicand has to be 0 or bigger. Now to solve this, you might want to put the 2 on the other side and then divide by a negative 5. But if you do that, you have to flip the sign. And I've told you in the factoring, remember this one? I hate negatives in the lead coefficient. So I'm just going to avoid that at all costs by moving it to the other side. Now there's no negative lead coefficient. I can divide by a positive 5. Signs will always stay the same. And you get x is less or equal to 2/5. Okay, so I really avoid this note by moving lead coefficients that are negative to the other side. Okay, and I would probably suggest that you do that as well, because guarantee some of you will forget to flip that sign. And just to show that, like, is negative 5 less than negative 4? It is, right? Divide both sides by negative 1. Is 5 less than 4? No. So you'd have to switch the sign. 5 greater than 4. I really don't want to do that at all. If you divide by a negative, you got to flip the sign. I don't want to do that ever. What happens when there's 2? Do both, and then think about it. So the first one is x minus 2 greater or equal to 0, and the other one is x minus 4 greater or equal to 0. Solve both. You get x greater or equal to 2, and over here you get x greater or equal 4. If you're bigger than 2 but also bigger than 4, do you have some redundancy there? Like if I tell you you're bigger than 4, isn't it automatic that you're bigger than 2? Yeah, so you just, this is like redundant. You know that word? Redundant? It's just like, it's extra information that you don't even need. Okay, let's look at the next one. X plus 2 has to be greater or equal 0. 3 minus x has to be greater or equal 0. So now we have 2 again. So just solve both and then think about it. First one would be x greater or equal minus 2. And then the other one would be, we have a negative lead coefficient. What should we do? Just put it on the other side. So leave the 3 there, leave the sign how it is, and move the x across. So now think about this. Think about the number line, and the number line is in your head. You got your number line in your head? In your mind's eye, everybody? What's in the middle of your number line? And what's on the left? And what's on the right? You have negatives on the left, positives on the... So negative 2 over here, you're greater than that, but you're less than 3 over here. So let me draw that number line for you. Here's negative 2. Here's 3. It says that you're less than 3, but you're bigger than 2. So it's all this stuff in between. So we can write that in one statement like this. X smushed in the middle, arrows pointing to the left. You're left bound on the left and you're right bound on the right. This is how you'd formally write that. Okay, so you have two situations. And neither of those is redundant. Remember in this one here, this one, they both were similar. So one of them was redundant. But on this one, you don't cross them out. You have to think about it. So we got one more try here. 2x minus 7 is greater or equals 0, and 24 minus 5x is greater or equals 0. Get 2x greater or equals 7, x greater or equal 7 halves. So you're going to be bigger than or equal to 3.5. What do we do on this second one? We've got a lead coefficient that's negative. Other side, and then divide by 5. So 24 fifths. It's like 4.8. So you're less than 4.8, but you're bigger than 3.5. So 7 halves is 3.5, and 24 fifths is 4.8, and you're in between. Do you remember drawing number lines like this, maybe in Math 10 on the domain and range? The closed circles means you touch the endpoints, and it's highlighted all the region in between. So formally, you'd say x in the middle greater than your lower bound. What's the lower bound? 3.5, which is 7 halves. And you're smaller than your upper bound, which is 24 fifths, that 4.8. And that's how you do it formally. How do you guys feel about these intervals? If you don't practice them, it will be very challenging for you to reproduce this. For this unit, these last two lessons are by far the most difficult in terms of relative difficulty. The first few units is a lot of review, and then it amps up the factoring, and then we get into these equation solvings for radicals. Okay, solving radical equations graphically. This is basically just calculator work. So I'll show you how to do this. Circle the left-hand side. And then just put this LHS, left-hand side. Circle the right-hand side, RHS, right-hand side. And in the calculator, you just type in the left side into the Y1, the right side into the Y2, and then you just check where they cross. Remember this in Math 10, where they intersect? So it's in the calculator, it's second trace, into the calculate menu, and then you choose number 5, intersect, And basically, if your window settings are good, then this is no issue. Now let's take a look at the windows they gave us. First of all, let's take a look at the Y windows. So what's the lower bound on the Y? And the upper bound? So you can see this on the window, -5 to 5. Okay, why do they choose those values? What do you need to see? You just need to see 4. And then you'll see a line just jet across on 4. This is what you're going to see. See if I can get a line tool. No line tool? Oh my gosh. Oh. Okay, we'll just use a calculator. So the window was -5 to 5. What was the X window they gave you? 0 to 20? -3 to 20, thanks. And what function are we putting? The second one's 4, and the left-hand side is square root of x plus 1? Like this. So there's the function, square root, and then here's the 4 jetting across. We want that spot right there. That's where the two functions are equal. That's where they cross. So you have second trace. So second trace, second trace, second trace into this calculate menu. We want number 5, the intersect feature. And then it's got this first curve, second curve stuff. If you can see it on your screen, just go enter, enter, enter. Sometimes you kind of move the cursor close to it and then hit enter, enter, enter. But here's your answer. When x is 15, the y is 4. There's your answer. Okay, so let's put that in there. This 15 comma 4. I think if you copied it down off the graph, it starts just to the left, does that. And then the other one is just jets across at 4. And of course I missed. But this is the spot we're interested in, where they cross. Should be, mine's just a little bit bad. I suck. But you get the idea. Okay. So the answer was 15 comma 4. Let's just check this. See, this is verify, is check. So x was 15 plus 1 equals 4 question mark. 15 plus 1 is 16, is positive square root of 16 is 4? Yes. Root 16 is 4. So that's how you solve these with your calculator. Now, if we were in the 20-2 or 30-2, I would be like, that's all you need to know. Done. But in -1, you have to do this algebraically. Okay. So if you take a look at the investigation, what are you doing to both sides? You're squaring both sides. What that will do is it will get rid of that square root symbol. It's just like the Pythagorean theorem when you're in junior high. You know, you have to square root and square both sides, stuff like this. Okay, so if you square both sides, you get x plus 1 equals 16, because all this square and this cancels out. And then you minus 1, and you get 15. And then you'd want to plug this back in just to double check you did it correctly. Now in the second investigation, they're saying, well, first of all, what's different between investigation 1 and investigation 2? Take a look at the difference. And this word right here, it's this word right here. That's the difference. So over on example 1, the radical is isolated. But over here, you notice that the radical is not isolated. What's in the way? This plus 3 is in the way. He's like, you know, that ugly friend. Just in the way. You know how sometimes you have that one friend in the group that everybody picks on? but they still don't get the message. I'm just kidding, you guys. I play on a hockey team with a bunch of young guys, and they're so mean to each other, and just like I just watch how these guys are, and there's always that one boy that they all pick on. It's just not fair, hey? It's like the ugly duckling kind of thing. So this 3, he needs to get out of the way. It's like, get the message. You need to go over here, buddy. And that's what happens. And then you can square both sides. Okay? But look at the right-hand side. Look at this nastiness. When you square that, you have to use FOIL. Okay? So this is really have to dig deep into your toolbox. Okay? So on the left-hand side, the square and the square roots just cancel. It's nice. You just get the radicand. Okay? It like basically, if you think about this, you are like unlocking it. Because if you were to write a radical as a power, you'd have a bracket to a power, a fractional power, and then you'd have to get rid of that fractional power to get it at the x. You're like unlocking it. Now on the right hand side, following your rules of equation solving, you got to square both sides. So we have to square everything over there. So we're going to repeat the x minus 3. And when you repeat it like this, you have a binomial, which we call FOIL. Got an x squared, and then a minus 3x happens again. It's a perfect square, plus a 9. The left-hand side remains the same. So you guys should be quite familiar with that process. Now what do you notice? What degree is this equation? It's degree 2. So we have to put everything on the one side, and the other side is 0, and then we factor it and solve. So I'm cleaning up the middle. And then what do I do with this minus 1 and this x? What do you got to do with it? I'll change color so it's obvious. You have to move it to the other side. Now clean it up one more time. I got x squared minus 7x plus 10. This one works out perfectly. It's 2 and 5, and they're both negative. And the solutions to this equation are x equals 2 and x equals 5. Okay. Now we have to check. It says confirm and verify. That's step. So our step 3 was long. Now we're going to do step 4 and verify. Part B, if you want to use technology to double check, that's cool too. But I'll switch colors for the verify. We're going to verify in blue. The original equation's up here. So let's plug in 2 and see what we get. 3 plus square root of 2 minus 1 equals 2, question mark. What's the square root of 2 minus 1? Square root of 1. What's the square root of 1? 4 equals 2. Is that a problem? What happened? Why didn't that work? Is one of them extraneous? Okay, so this one did not work. I just double checked the key, and we have extraneous, which means we don't use that one. Okay, now plug in 5. See what we get. 3 plus the square root of 5 minus 1 equals 5, question mark. What's the square root of 5 minus 1? Square root of 4. So 3 plus 2 is 5. 5 equals 5. So yay. So we don't use x2, we use x5. This is the solution. Okay, we're almost there, guys. Got a little bit of reading to do and then a couple more class examples. Yeah, it's on the next page if you take a look at it. If you're already done copying, you can get a head start. Some people still writing. So, yeah. Okay, so in investigation 2, one of the solutions can be verified but the other one could not. Can you explain why solving a radical equation by squaring both sides of the equation can lead to an invalid solution? The answer is provided in the section below. The process used in solving investigation 2 led to an answer which is not one of the roots of the original radical. It is, however, a root of the non-radical equation in step 2 formed by squaring the original equation. This is because the process of solving a radical equation is based on squaring both sides of the equation. If two quantities are equal, then their squares are equal. The converse, which is the backwards of that, is not necessarily true. Two quantities which have squares that are equal will not necessarily have equal quantities. You can see that negative 3 squared is 9 and 3 squared is 9. So their squares are equal, but originally they are not equal. So this is why you can, from time to time, find yourself with an extraneous root or extraneous solution. It's basically the one that doesn't work. Okay, so extraneous is the reject. You say no, that one does not work, it's rejected. And for this reason, it's always necessary to verify. Here are the steps for solving radicals. Step 1, isolate. Then square. Then solve. And then verify. So you isolate the radical, square both sides, solve the remaining equation, and then you verify, checking for extraneous roots. Okay, and then in lesson part 1, this is lessons two-parted. These ones are of the relatively speaking easier variety, and then in the lesson 2, that's tomorrow, they get pretty freaky, if you know what I mean. These get harder and harder. So at first, these will seem quite straightforward. So are these radicals isolated? So you just square both sides. Another way to think about this is like, they're both radicals, do you agree? So that must mean the insides must be equal. X plus 3 must equal 3x minus 5. If you think about it that way. Or you could also think about it this way, where you're just like, okay, well, if I square both sides, then I unlock the radicands. Now I just isolate the remaining linear. This one's linear. How do you solve linear? This is like junior high stuff. How do you solve a linear equation? Put the x's on one side and the numbers on the other. So I'm going to put the x's on the right. Why? What do I hate? Negative on the lead coefficient. So I'm going to put the x's on the right and put the numbers on the left. 8 divided by 2 is 4. Okay, next one. Oh, we have to verify. Did we verify? Okay, let's check it out. Punch in a 4, you get square root 7 on the left. What happens when you punch in a 4 on the other side? 12 minus 5 is 7. So that one's good. Root 7 equals root 7. Done deal. Let's take a look at the next. Oh, this one's identical. Square both sides, what do you get? X minus 3 equals to 3x minus 5. Same idea, put the x's on one side. This time it's negative 3 plus 5, you get 2. 2x, divide by 2, you get 1. Now verify, what happens when you plug in a 1 there? And if you put in a 1 there, so you get the square root of negative 2 and you get the square root of negative 2. So this okay, kind of. So like mathematically it's okay, but like in high school we don't ever do square roots and negatives. So you just say like non-real solution. Because you can't take square roots and negatives, that's non-real. And if we could connect this to what we started with, what did we start with? Finding restrictions. So could we find the restrictions on these two equations? What's the restriction on this one? X minus 3 has to be greater or equal 0. X has to be greater or equal 3. And you can see 1 is not greater or equal 3. So you'd say x equals 1 is a restricted solution. It's not allowed. It's too small. The reason is you end up with square rooting of negatives. So like technically it's okay, but high school it's not okay. Like in a university situation, it'd be fine. It'd be completely fine. If you were taking like a... Anyways, whatever. Moving on. Alright, let's take a look at this one here. Now you have to ask yourself,
Good afternoon, everyone. Can all teachers please show the each reward choices for Wednesday? Everyone will have an opportunity to sign up tomorrow in period 3's class. Thank you.
no, you have to stay. Okay, we are going to have to throw down a pause on this video. We'll pick it up where we get left this off. Okay, class example 4. You are going to isolate the radical. You're going to say, well, Mr. Lineweber, I can't. I'll just give you a tip. If you square both sides right now on the left, you're going to have to FOIL out 2 radicals, and that's bizarre and hard. So right now, I'm going to say, put the radical on either side. Otherwise, the squaring both sides gets very weird. So let's just move the root x minus 3 to the other side. And all we have to do is switch the sign in front of it in order to do that. Is everybody okay with that? Now, we have to square both sides. Now the left side's very easy. You just get x. But the right-hand side, what do you have? You have this. Now, how are you going to FOIL that? Okay, so let's try this out. See if you can remember back to your foiling radicals. Remember unit 2? Okay, 5 times 5 is 25. And then we have minus 5 of these. And then we have minus 5 of these again. And then the very last one, a minus times a minus is a positive. And what happens when you take a radical times a radical? Check my whiteboard. You remember this stuff? What's root 3 times root 3? 3. Good. So the radicals just go away. So you're just left with x minus 3 on that last one. Now you have to isolate the radical. again. Okay, so these two are going to combine. You get minus 10 of them. And then all this other stuff, you're going to do like terms with it. All this other stuff. And put it on the left. Okay, so on the left we have an x. I'm going to move this 25 over. And I'm going to move these two terms over. So you have minus x and plus 3. I'm just switching the signs. Just switching the signs. 25 came over, x came over, 3 came over, switch the signs. So this is nice. X minus x is 0. Negative 25 plus 3 is negative 22. Divide out negative 10. And that's positive 2.2. And again, we have to square both sides. This is fun, right? Okay, square both sides. 2.2 squared. 2.2 squared, I got 4.84. Add 3, 7.84. And done.
Please excuse the interruption. If anybody would like the opportunity to sign up for these reward choices, you could do it today in period 3 or tomorrow in period 3. Thank you.
No, I can't.